In this video, I'm going to demonstrate just a couple of typical diagrams that I would make up for a customer, which later become artifacts of the project. And, a lot of times you work off of user stories. I've worked with those before. Those can be a little cumbersome, but they're also very productive. But most of the time, since I work by myself, I really just listen to the customer. I take notes, and then I start to make these database diagrams. And they seem to really appreciate that because then they can see their project coming together right away. These come on real early. And I've only made 3 of them here. In a big project, there'd be a lot of them. So let's, this is my diagramming program here. So I just called it a simple invoicing application. So a simple invoicing database. And these are the invoice relationships and the product relationships and the customer relationships. And so I kind of chose this as a demo because it highlights different things like one-to-many, one-to-one, and many-to-many relationships. So I can demonstrate all those. So let's start here with the invoice relationships. Usually in these diagrams, you put your primary table right in the center like that. And so these would be the fields. There are better diagramming programs that'll actually add like the data type to expect and stuff like that. In addition to that, these arrows that point for the relationships, they really just go from table to table. They're not pointing at one specific field like you might see in query builders and things like that. But this is good enough to get the idea. So we have these invoices, and each invoice has a customer, obviously. So we bring in the customer table, and notice I got the little asterisk there because I say this is an incomplete table representation. The table's just in here just to show how it relates to the invoices. These other tables, though, these are complete representations. If there was more fields, we'd make longer ones, longer boxes. So we got the invoice terms, the invoices, invoice items. Product master is very similar to customers in that this is an incomplete table representation. This just shows how it's related to these invoice items. One thing about this, it's again, I'm trying to demonstrate that I have the knowledge of, is there's a reason why some of these are 1 to 0 or many, and some are 1 to 1 or many. And it basically is just a way to demonstrate the logic that you're going to follow when you start to build. You can have a customer in the database that hasn't had its first invoice yet. Just to load that customer up into the database, start their record, get it going. So you have to be able to do that without having an invoice already. But you wouldn't want to make an invoice without at least one item. So in this case, it's sort of like a restriction, a constraint, that in order to create an invoice record, you're going to have to first create an invoice item record. Now this one here is a one-to-many relationship in that every one product from the product master table will be listed in different invoice items, but you're going to have a lot of products that have never been listed on an invoice. So you're going to want a nice long product list, and probably 60% of those products will have never been listed on an invoice. They're just there because you have a nice comprehensive list and doesn't necessarily match your stock. That's very common. Okay, so that's a quick overview of the invoice relationships. And let me move along to the product relationships. So here's the product master with a little bit more of a complete table. Now, if this were a real database, of course, there'd be a lot more fields than that. But one of the things I did, well, real quickly, this house has some one-to-many relationships here. Product types, product descriptions, product manufacturers. Those are all in the 1 to 0 to many, 1 towards 0 to many relationship. But these are a little different. A lot of times what you want to do is you want to try to minimize the fields that have null values in them. So let's say I would add a product notes field into this product master table. Well, I might only want to take notes on the occasional rare product record. So you don't want to wind up adding a null product notes field, which is probably a memo field, and they're even bigger than character and text fields. But they'll all be null for every record, for most of the records you have in this table. So you break it out into another table, and that's now in a 1-to-1 relationship, or actually more specifically a 1 to 0 or 1. And so most records will have the 0 on that side. But for the few that you do want notes on, you now have that in a 1-to-1 relationship. I forgot what that's called, but there's a way of optimizing your database, and you run through a process where you try to remove fields that have a lot of null values to another table. and that way you can reduce those null values drastically. This is very similar, but this would be more like a calculated table where you might go out and calculate the amount that's been sold in a certain time range, or the average cost for buying them new, the record cost, the highest that they ever were, or maybe the lowest that they ever were, and the date that those two occurred. Another thing, by the way, just caught my eye is I have these fields in here, updated on, created on. A lot of people will build databases that every single table has both a created on and an updated on field. I don't usually do that. I don't usually feel the need. Like, I might want to know how old a manufacturer's record is, but I don't need to know the date that we figured out what country that they're in or what state or province that they're in. That's not really necessary. I just need to know how old the record is. But on this one, I need to know when these values were calculated. So that's a little bit more important for me to track the updated on rather than the created on. But stuff like types and descriptions, I don't really even need to know the age of those records, usually. So that's just sort of my own opinion on that, what they call timestamp fields. All right, so moving on to the customer relationship fields. The reason I did this diagram to demonstrate is to show you how a lot of times fields can be removed to a different table based on logic rather than optimization. Over here, this field, product notes, was removed from the product master table for optimization purposes. Over here, it's more like a logic reason. You don't really want to list up all your contact information in a customer table, even if you only plan on having one customer or one contact per customer. So this can be in a one-to-one relationship, or it can be a one-to-many relationship, but that one would assume that if you're going to add a customer, you need at least one contact for that customer. And same thing with addresses. You probably need at least one address, but you don't really know what kind of address type. Is it a shipping address? Is it a P.O. box? Is it something like that? So this is a very common way to lay out different customer fields. And you separate these fields into other tables based on logic reason and grouping reasons and ease of management. Now, if you notice on this one, I would have both a created on and an updated on, because I want to know how old an address is, and I also might want to know when we last updated it. So that would be an example where I'd use both of those fields. But that would be something I would discuss with the customer. They might say, no, put timestamps on every single table, even these little ones like address types. Okay, so I'll end this video there. I hope that gave you a good overview of some of the types of diagrams that I would produce and give to the customer that they would keep as artifacts of the project and its development.